This course is for any one that has an engineering background in electronics and mechanical engineering or chemical engineering as well, and for physicists.
Hello and welcome back to Future You, the podcast brought to you by graduate careers experts Prospects. I'm your host, Emily Slade, and in this episode, we take a look at the new Biomedical Engineering MSc, available from the University of Sussex.
Hello, I'm Carlo Tiseo. I'm a lecturer in engineering at the University of Sussex, the School of Engineering and Informatics. I will be the course convener for the MSc in Biomedical Engineering, which means I will be in charge of the course and on the management of the course. Myself, I'm a biomedical engineer. I graduated in Italy and then I went to do my PhD in Singapore in rehabilitation robotics. Then after a period of research at the University of Edinburgh, I moved to Sussex in 2021.
That's so cool. You've been all over the place. So to begin with, what is biomedical engineering?
So biomedical engineering is a subject that emerged in the 60s and 70s to start to, as a response to the demand of professionals that were interdisciplinary, that were able to handle the machines within the hospital, and so be able to provide service in the hospitals, but also to sell and give support to hospital and doctors for the machines. So until the first half of the century, there were not much instrumentation involved. Instead, from the onwards, we have an increase of instrumentation. You need to consider that, for example, X-ray that we consider medical standards now is most an entry-level diagnostic, actually was cutting edge in the First World War, where actually Marie Curie and her daughter went on the field with the field ambulance with an X-ray machine to test it. So as the medical profession evolved and the technology deployed in the medical field increased, then we had the need to engineer specialized in handling that type of problems. And different from other branches, intrinsically multidisciplinary, because you need to deal with many aspects of engineering and only with the one single field.
Can you describe the goal of the MSc in biomedical engineering?
Our goal is trying to answer to a need of an increase of manpower in the biomedical field. We need to consider that all the developing countries have an aging population, so there will be an increase in demand on medical services. At the same time, we have a reduction of active population, so it's the population which is not either studying or is not retired. So that reduction, which we have less people able to provide services, and services here is intended at large, so basically work power, manpower, and then you have a higher demand, there is a higher need for medical services. So a huge drive is to increase the automatization level and the increase of diagnostic and therapeutics devices that are able to be more effective and efficient in delivering medical services. And so we will need more people to take care of that machines that will increase in number. Compared to other countries, historically the UK has not had the strong demand of these courses from the students. And one of the first MC courses in biomedical engineering was in PL, and until 2 years ago was the only offer in UK.
Oh wow!
Compared to other countries where early in the 90s were established as faculty at national level, and not only in center of excellence.
Mm-hmm. Oh, perfect. So, who would you say this course is for?
This course is for any one that has an engineering background in electronics and mechanical engineering or chemical engineering as well, and for physicists. The reason why we added also physicists is physicists have a good theoretical background to learn this information that is taught, and the subject was taught within the course. And historically, the first that did this transition, and many of medical devices' first invention were physicists rather than engineers.
So, for students that are not in the UK or those that might want to work remotely, is there an option to study the course either online or part-time whilst alongside work?
So we have an option for part-time, but there is not option for remote. This because it's an intensive. There is an intensive laboratory use, both for engineering and anatomy subject. We will discuss that later in more in depth. But so since we have that strong practical component, we have not designed the course to be attended online.
The course is a collaboration between the engineering department and the Brighton Sussex Medical School. Is this the first time that that's happened, and how did it come about?
So for a taught course, yes, there are intra-faculty collaboration for Center of Excellence like Sussex Neuroscience, but this was the first time where we got together for establishing a taught course.
Mm-hmm.
It came about that there are strong collaboration or attempt to collaborate between the two schools for the research in the latest year, and we are also trying to build a biomedical engineering center for research, where to build around also our taught infrastructure, so our courses. And this is the first step, and we chose the master because it's a program where you can deliver to a small group of people effectively. We also need to expand our expertise to cover a bachelor degree. This 4 years. There are a lot more courses, something that the adaptation is to be given for the students, and the type of support is different. Because are less mature as an individual, they have not had any previous experience for the bachelor in university. The master has other need. So for us, it was the first step into expanding into a wider offer in biomedical engineering, to be able to give the best possible quality to our students for their program, without exposing too much, overcommitting too much the resources of the university. So it was a balance. We had to identify a program that was for us feasible to make at an excellent level. Mm-hmm. And also we identified the MSc as the first step, increasing our formative offer in biomedical engineering.
Perfect. So can you tell us a bit more about the course? What do you learn?
So the course itself is in the first semester we give the basis. So for the subject, so we do anatomy, which is an introduction to anatomy. So the anatomy that is needed to help engineers to acquire the terminology and understanding of the human body, and the function of the different parts of the human body to effectively be done in this profession. Because you need to speak with doctor, you need to understand what they're speaking about, you'll be able to design things that are compatible with the human body, both in morphology and function. So you need to study the concept of human body. Then we will do another introduction course in physiology and biochemistry. We had to add the biochemistry because not everyone coming inside this master is expected to have the chemical background. So we have decided to give an introductory period at the beginning of physiology, where we give the fundamental chemistry that is needed to understand the body. The idea is to run the two module anatomy and physiology on parallel, because while anatomy explains the morphology and the anatomical functions and names, physiology instead allow them to study the function and how that the chemistry of the different part of the body part and what is the function within the physiological state of the human body. Okay. And then we do medical instrumentation. Medical instrumentation is basically a course where it goes through standard medical instrumentation to understand how it's been designed, how it works, in order for our students then to first learn how a medical technology is developed, but at the same time to learn the fundamentals of what they need when they go to work. And the last subject is signal processing, and this because we are acquiring signals every time we do a measure or we elaborate information. The information is a signal, so it's a fundamental skill to be able to elaborate signal and process signal acquired by sensors. So then during the second semester we have image processing. So image processing process images, which is used intensively, for example, in diagnostics, where you are acquiring imaging and you are studying imaging to make a diagnosis. So you have, for example, the ultrasound scans are received online image processing when you're looking at them. When you look at X-ray, you may have signal processing, and there may be also is essential to acquire images like CT scans and MRI. Without image processing, you will not have any image there. Okay. And then we have wearable technologies. So wearable technologies is a course that study all the wearable technology, both for civil and medical use. So it's not only focused on medical. There is a predominance of medicals, like we look into exoskeletons, we look into wearable sensors for tracking physiological parameters, but we also look in more commercial wearable technology like the smartwatch. And then we have another two courses in the second semester to complete our formative offer, which are biomaterials and biocompatibility. In that, we will study basically how the materials react in contact with the body, and which material are suitable for that, because you don't want the material to poison the human body. It has to be resistant, because a human body is a very aggressive environment. So if you implant something, you normally degrade the material. So there are only a few materials that you can implant and they will remain stable within the human body.
Oh, wow. I didn't know that.
And also, if you put in metal, you don't want to release heavy metal, so you need to choose materials that are suitable to not poison the person that has an implant.
Yeah, ideally, yeah.
And the management, which is a course where they teaches the fundamental of management, that are a skill that are expected from many engineers, because as a part of an organization, it will be required to manage some tasks, manage people, understand about business. And so we have that business management program delivered by lecturer from the business school that teaches the fundamentals for the skills required to be a part of a company or a organization of any kind.
Amazing.
Then, if I can do a last remark, we have also design our activities across the course to not only focus on hard skills, but actually what we want is to help our students to develop their soft skills in terms of problem solving, lateral thinking. So since biomedical engineering is a multidisciplinary subject by definition, you need to be able to acquire a reasoning process, problem solving processes which are translatable, so you can apply to the different fields without, even if you don't feel to be an expert, is not a problem. When you go in a company, you may ask for an expert, but most of the time you need to understand the general process and be able to deliver a solution. So we have designed practical activities, laboratory activities, group projects, and the way of feedback that we want to give our students, which is not structure, but we give workshop, seminars, and laboratory where the students can and have to be effective in learning the subject, ask for feedback rather than structured feedback.
Yeah.
This is because one of the first, the most important things when you go on a job is to understand when you have reached the limit of your knowledge and you need to ask for help, and be able to recognize the level of your knowledge in a field and be able to go and ask for help is an essential skill, because the company can always provide you support or training, but you need to be able to ask for it. And so we believe that we have to build a structure that allows students to understand how to deal with that kind of environment into a safe in a safe settings, because that's what they are when they're learning. It's a safe setting where they can test and understand how to approach those type of situations.
That's really important. That's really good. Thank you. So what equipment do students have access to?
Okay. Equipment, we have the Laboratory of Anatomy, where they will have some medical instruments like ultrasound scans available there, both portable and more traditional. They will have access to specimens that have been dissected by the medical school. So they will study, where they can study implants, how they evolved over time, because when you have an implant in a body for a prolonged period of time, especially early implants, older implants, we start to see the problem of not having a perfect biocompatibility. Okay? And so they will study that, things that, then we will have all the engineering infrastructure, so workshop, electronics lab, the mechanical labs, fluid dynamics labs and thermodynamics lab, wind tunnel to simulate, to understand, for example, how the hot wire anemometer works. So when your anemometer is a sensor and measure the flow rate. And so, for example, if you attach a person to a respirator, you want to understand what's the flow of breathing to understand the effectiveness of the breath of the patient. And so you put an anemometer, and those anemometers that are put in the mask they have two auto wires, because you need to understand one that is gets through the flow of air and it measure the flow, and the other that give you the reference of the room temperature that you need to remove as bias. In order to allow that to measure, you have actually an aerodynamic shield. So you create a shield in front that allows the flow that as exhale to bypass one of the two wires. So you can get the delta and remove the element due to the temperature of the room. And that will allow to measure. So that is a typical example of a medical instrumentation that is simple, but if you see, you have electronics, because you need to understand how the electronics of the hot wire, which is a resistor, works, how to measure and how to design a circuit that allow you to connect these two resistors together, as well fluid dynamics to understand how to bypass and create a shield in front of one of the two in order to acquire the measure.
Cool. So cool. So after students graduate, what career opportunities wait for them?
So always you say, okay, a researcher, hardware developer, those are possible, but are limited. So most of the workforce is acquired is actually into targets hospitals and medical device companies, because there is a strong demand for in the hospital and medical institution in general. They need people inside to manage the infrastructure. This does not mean only intervene. That often the intervention and the support is given directly by the company that produces the device, but the management allows understand when it's broken, when to call the company to understand the depreciation, to understand when it's worth to update, to analyze, to prevent bids. And all this is an expertise that hospital and medical center in general have to have inside in order to balance the offer of the market, the demand from the clinicians, and try to understand what's the best choice for the institution. And on the other side, on the company side, the device often are very complex to use. The medical professional do not have the skill set to use those, so it's not just often a sales job that the company do. It's actually sales and support and assistance. So normally are called product specialists, as people that know very well one product, and they go on site, they provide support, they give technical assistance to the doctors, and so that's why it's important to be able to speak both languages, the clinical languages and the engineering language, because then on the company point you need to go back and report the problems and need of the customer to the company to go through R&D and improve the product, identify new challenges that were not foreseen before.
Perfect. Thank you. What is the most exciting aspect of the course for you?
The criticism, so the ability. I've chosen bioengineering because it's an eclectic subject.
Mm-hmm.
So you're not always doing the same thing. You don't specialize in one single aspect, but you should be a professional as a whole across the field of engineering in order to understand the problems you face. And that is at the same time challenging, but then is also exciting, because it's you don't become expert on one thing. And then the other things that I think is exciting is that differently from other engineering is an engineering where normally you have a gender balance. It's very close to gender balance in Biomedical Engineering.
Oh, wow. Why do you think that is?
I think so if we look in general, all the subjects, normally female students are the best students statistically. What I think, if then you look at the demographics, normally subjects were are more empathic or societal impact, which is more direct, more on people, tends to have higher presence or females. If you look nursing, medicine, psychology, biomedical engineering, all subjects that are STEM, but differently from other subjects that higher perceive societal impact. And that I think is a drive, is a different is interest. And that is very important, trying to find programs that diversify the offer within a school to find programs that may interest the wider audience possible. And to, well, then we know statistics. Then if we look in STEM, gender balance in general, I think it's too early to speak at university level, to look at that from a gender balance university level, because it's too early. The real gap between the two genders there is not really evolved yet in terms of time that the societal roles is almost similar when you're a student. What I personally, and here this is a personal perception, if I look at a subject like medicine, for example, you look at historically, there has been, before even when it was less accessible to women education in the 70s, the 60s, 80s, my parents' generation, in medicine, we're almost a balance between the two.
Mm-hmm.
But then if you look, I'm taking that course because I now look at the director of units, they're predominantly males. So we may need to look at support on gender imbalance in another, maybe it's later I believe it's later. And the tools are not simply to say, okay, I need to have a parity in the university. In university, you need to make an offer that is inclusive. Then, in the career, and when you get older, and the role in the society may change, then you need to find a way to balance the career to be effective. Otherwise, is a number policy. But that's my opinion.
Yeah, that's brilliant. Well, that's everything from me. Thank you so much for your time today.
Thank you.
Thanks again to Carlo for his time. For more information on the course, you can head to prospects.ac.uk. If you enjoyed the episode, feel free to leave us a review on Apple or Spotify. For a full-length video version of this episode, check out our YouTube channel at FutureUPod. Thank you, as always, for listening, and good luck on your journey to Future You.